All right, so we're live with a new series that I'm going to set up, which is how to prepare for the Google Professional Machine Learning Engineer certification and kind of walk through all the different things that are associated with that particular certification. A few, maybe things about the Google Machine Learning Engineering certification. One is that I did uh, take the test and I did pass it. I'll give you a little bit of context about what I was thinking when I first took it. I mean, I was actually pretty sure I would not pass it, but I had a hope that there was maybe a possibility I would pass it, and part of it was because several years ago I attended the Google conference in the Moscone Center, and I remember they, on a whim, they had offered, or me on a whim, decided to take the Google Professional Architect certification, and they just had it at the conference. I thought, oh, let's try it out. Let's see if I know Google well enough, and I think I knew it well enough to pass the certification. I did see a lot of people with upset looks on their face as they came out of the certification, and I think one of the reasons that I was able to do well on the Google architecture certification is that I knew AWS. And so I think that's one of the more interesting um, like side effects. What I've discovered about Google is that, at least the way that they think about certifications, is that I think in some sense they're more realistic than AWS. AWS, I think, is a lot more by the book, like do this, this. You have to know all the terminology, all the services. What I found about Google in passing two of their most difficult certifications, the professional architect and then the professional machine learning engineer, is that it tapped into some of my experience either as a software engineer or as somebody that's doing machine learning engineering or building solutions on the Google Cloud. So in some sense, it might be more difficult to just study, by itself, the Google exam without having real experience. And so I think there's pros and cons, right? The pro is that I think a lot of people might respect these certifications a lot more because they're a little bit more difficult to just read a cheat sheet on some course preparation website to prepare for the exam. You basically do need to know the concepts. And so I would say that's probably the biggest thing to remember with the Google certifications in general. So let's get started though with that's just the context. I'm gonna share my screen here, and I'm gonna dive into the just the overview. So Google machine learning, and I'll give you some starter tips here. So to start with, I'm gonna go to my screen, and we'll move into this mode. Make this a little bit better, bigger. There we go. So the a couple of things to point out. One is that there is some exceptionally good documentation available from Google, and the machine learning crash course is quite good. And I think this is something that I would recommend that people go through. So this isn't machine learning engineering specific, but this is just the way Google sees machine learning. So if you have not gone through this tutorial, I think it's going to be impossible that you will do well on the Google machine learning certification, right? This is bread and butter, core foundational material, and it's actually very good. In fact, you have people like Peter Norvig, who is an idol of mine, who inspirational person, and they give you a lot of really good instruction here about things. So that's one thing. Now, let me point out a couple other things as well. Like, notice this under advanced courses. If you select this tab, there are some new kind of surprising things in here that I think are worth paying attention to. And in particular, I think it is important to look at all of this content as well. And so why is this important? Because it covers the theory of a machine learning system, but in the context of how Google sees the world. And if you go through here and you look at, for example, clustering, they talk you through all the different things that are associated with clustering. So I think if you don't go through the machine learning material that they have on Google's website and take notes, I think you're really going to have some real problems with studying for the exam. On the flip side, if you do, you're really putting yourself in a great situation to be successful. Now, I'll also point out a few things that I say to students that I teach in at the university level, and one of them is whenever you come up with something that seems like it's a new term, you should have on the side of where you're studying a Google Doc or a notepad or something like that, where you're writing down the thing. So let's say, for example, you look at the word Gaussian and you're like, what is that? What does Gaussian mean? Well, you better write it down, because if you see it here, very likely you're going to see it in the future, not only on the certification exam, but also on some real world problem. And so this would be a great thing to go through and write down, make sure that you understand every new piece of terminology. And this is something that really trips up people that are new to a topic, is they don't write down the terminology and they feel like the material is more complex than it is, when really it's just new terminology and new jargon. And this is, I think, one of the biggest challenges for people new to technology, is they get overwhelmed by the jargon when the concepts many times are actually reasonably um, straightforward once you strip away the jargon. So that's kind of a pro tip there. Now, another thing to be a little stealth thing here to talk about with the Google machine learning certification is look at this. This is also a no brainer, that if you're not using the machine learning glossary and essentially looking things up, and I would say probably you should know every single thing in the machine learning glossary, also you're going to have big trouble not only being successful on the Google exam, but also just in the real world. Like this is curated by one of the top companies in the world, and they have a whole list of things here that are really important topics. If you go to C, we have candidate sampling, categorical data. Like this might be something that could trip somebody up initially, is like they may understand a categorical data, but they want to get a better understanding of all of the different components of categorical data and how it relates to machine learning. Well, there's a really good definition here that you can go through. So this is another really good place to just prep your knowledge, make sure that you have all this stuff, inside of your tree of information that you're going to use when you're taking the exam. So I think these are a few things to really point out, is the official foundational courses here, and also the guide and the advanced courses, right? These are all really good things to study. Now, the other thing that I think is a good one to point out is there's two other courses that I think that are probably not widely known, that are really good material. One of them is problem framing. And if we take a look at problem framing, this is one of the problems that I think is it really important in terms of understanding the real world machine learning, is that you should be able to frame a problem in the correct way and make sure that machine learning is actually the right approach, and also that you're using the correct machine learning approach. And so this is definitely something that can get you in trouble when you're studying for a machine learning exam. In fact, I'll just talk generically, because I've taken multiple machine learning engineering exams, is that this is a very common place to trip people up, is if you don't understand problem framing, I don't think it's possible you'll pass any machine learning exam. And so fortunately, again, there's some really good stuff here about problem framing that you can go through and really test your wisdom on. And in fact, I think this is something I really would kind of dive into very, very deeply, is to make sure you understand problem framing. The other one that's, I think, related to machine learning engineering is data preparation and feature engineering. And there's some really good workflow diagrams here that walk you through some of the things that are important to study. So we go again to, problem framing, and then we have this course which talks about constructing and transforming the data. And this is important to know because when you are, interviewing for a position, or going for the exam or whatever, you're going to need to know the ins and outs of how data preparation works. And there's some really good information here about, sampling and splitting, and all kinds of different questions as well. So I would say those are really the kind of the table stakes to understand the machine learning exam. Now, I'll also go to the exam prep. So let's go to Google Machine Learning Professional. Let's go. Here we go. So let's go to the official page here, and let's just walk through some of the things that are important to be aware of. So the exam itself, I've noticed here, it really is making sure that people understand what it's like to be an engineer, right? So you're going to know, you're going to need to know how to do software engineering, and so framing problems, right? They're mentioning this in the exam guide, critical, and I can vouch for this. This is really critical. Now, architecting, what this is really going to mean is that you have understanding of the Google Cloud Platform. A great way to practice this, and in later live streams, I'm going to talk about this and do it in person. Is I think the quick labs are really one of the best ways to understand this, and also the free tier. If you're not building stuff on the Google Cloud or using labs, I'm sorry, you probably won't pass the exam. And I don't think it's possible to just, without using Google Cloud, pass the exam. You have to know how cloud functions work, and how, to launch virtual machines and use App Engine and Cloud Run and the build system. Like, if you don't know that, you won't pass the exam. So I think these two right here are critical. And I think probably for someone that didn't pass the exam, they probably didn't do this, and they probably didn't do this. That the rest of it is also very important: designing systems, developing models, orchestrating pipelines. But I think these are the kind of the things that are easy to forget about, because maybe you're focused on Kaggle or focused on classic statistics. But these are really more about the real world, framing a problem and to architecting it. Now, in terms of the exam, one of the things you can do, and I did do this, was take the exam. Take the exam online. I've taken one in person. I think I mentioned I took one at Moscone Center in San Francisco, and that was actually kind of bad in a way. I think when you take an exam in person, there are a lot of strange things that will disrupt you, like somebody next to you, making loud noises, or people walking in and out, and I find it to be very, very disruptive. I think the online process, while it's a little bit annoying because you have to like take pictures of your room and all this stuff, first of all, I don't have to drive somewhere, and I don't get interrupted by people. So I would probably lean towards, this is what I would recommend. In fact, a long time ago when I lived in the Bay Area, I would drive like an hour to take an exam, and it was just a nightmare. So I think that this is an awful process to go to a location. Okay, now in terms of the exam here, if we take a look at the actual material, let's look at the exam guide. So in terms of the exam guide, the things that are important to be aware of are, again, framing the problem. As someone who has actually written machine learning exams for large cloud companies, and been involved heavily in the process, I can vouch for the fact that when someone gives you a document that says what's on the exam, if you don't take it seriously and you don't have a story for each of the bullet points, you're probably not going to pass the exam. So likewise, they're telling you exactly what's going to be on the exam. It says, look, you better know problem framing. And in fact, they start with it, right? Like, that's how important it is. So you're going to need to know how to translate business challenges into ML use cases. And also, when is the best solution going to be available? Like, you don't always need to train a model. Sometimes you may want to use AutoML or an API, right? And in fact, Google does have these capabilities. So if you're not using the Google Cloud Platform and you haven't tried AutoML with Vertex AI, and you haven't tried the computer vision API, you're going to really struggle with questions because you haven't personally done that. And so not only do you need to know about, how to train a model with TensorFlow, but you're also going to need to know how to do this. So the two ways to learn this would be to use Qwiklabs, one, and two, use a free tier account. And then also the next step would be defining model output and how to solve a problem, know how to deal with incorrect results, how to identify data sources, and then defining the problem. So this is, classic again on every certification I've ever taken, even ones outside of machine learning, they talk about this. You have to know what classification is, regression is, clustering. And for example, clustering uses unsupervised machine learning. You're discovering the labels. Regression, you're finding a numerical answer, and it's working on historical data, so it's supervised. Typically it's you can do logistic, and you can also do linear regression. Logistic regression would fit more into the classification, but mostly when people talk about regression, they're referring to the fact that you're predicting a numerical value that's continuous from historical data. Classification would be things like binary, right? Yes or no. The outcome of the model predictions, so input features, predicted output features, defining business criteria. So, kind of questions around the business success, as it relates to ML. I think this is really good to know. So you should read through, I think, the official guides that I mentioned earlier. This is where you're going to pick up that kind of information. All of this will be picked up from the guides. And then if you go into identify risk to feasibility of solutions, right? So assessing the business impact, ML solution readiness, responsible AI. Now, what was nice about this is if you remember that Google has, in fact, a whole course on responsible AI. So, it is something that you have the ability to study on your own. Now, as I mentioned in the first part of this stream, this is, I think, one of the places that will catch most people that are data scientists by surprise is maybe some of the people that are doing Kaggle very frequently or even work currently as a data scientist that want to get the certification. They might ace this, right? Like, I think that would be, with a little bit of study, it should be pretty easy. But this, if you're a data scientist, I think you're going to have deep trouble. And just to be honest with you, I think if you're a data scientist, this is where you're going to probably need to spend the most time. Now, what are the things that you need to know about? Well, look here. There's talking about designing reliable, scalable, highly available solutions, choosing the appropriate service. So this is kind of a classic problem that AWS gives you as well. Like on AWS certifications, they'll give you a bunch of different services and ask you to pick the right one. So here's where things get tricky is if you've never used the services, even though you may know conceptually like the open source term for the service, if you don't know the cloud's name for it, like, here's a perfect one. Cloud Build. What is that? Who knows what that is? Unless you've actually gone into Google Cloud and used the build system that they have available, Cloud Build, it could mean anything, right? Like, and so you need to know how it works, what the hooks are for it, actually deploy code through it. Like, for example, you could use Cloud Run, which is a container-based microservice framework on the Google or platform as a service on the Google Cloud. If you hooked up Cloud Run and Cloud Build, that would be a great experience for you so that you would understand how to actually build ML services. Likewise, some of these other things might be easy if you're a data scientist, EDA, feature engineering. But here's some stuff I think that's going to be a struggle for people that don't have software engineering skills is making sure that you understand what are the logging and management systems on the Google Cloud. For example, they have Stackdriver. What are the automation tools? Like, what does it even mean to do orchestration? Usually they mean infrastructure as code. What are the monitoring tools that are available? And then also serving. How do you serve out data and models on the Google Cloud? Vertex AI is their platform. That's definitely one of the options. And then also choosing the appropriate hardware options for the Google Cloud. So this is another one that if you don't have experience with the Google Cloud could trip you up. is that not only do they have CPU and GPU, which I think many people that are data scientists know about, but you also need to know about the TPU, which is TensorFlow Processing Unit, which is an ASIC. So it's a customized chip designed to work with TensorFlow, and also edge devices. So where would you learn about all these? Colab notebooks and also Vertex AI. Those are the two locations where you would learn all this. And then designing systems that are secure. So I think with this stuff, you could actually just play around again with Vertex AI and some of the quick labs. Now, in terms of getting into the next section here, designing data preparation and processing systems. Fortunately, this stuff I think is fairly straightforward. Exploratory data analysis, if you have any experience with data science. Building data pipelines gets a little bit trickier because you'll need to know about how to handle data leakage, those kinds of concepts. But there's a lot of good documentation outside of Google and inside of Google. I wouldn't say there's necessarily anything specific to Google. And then in terms of creating input features or feature engineering, we have ensuring consistent data preprocessing, feature selection. So these are all things I think that there's a lot of good tutorials on. So I don't think this is a controversial section at all. It'll be fairly straightforward. Now, this is in the developing ML models. I think there are some interesting things here that are unique to the Google Cloud, and in particular, choice of the model and framework. So you should know a little bit about TensorFlow. Also, you should know about transfer learning, right? The concept of taking a model and just tuning it for your purposes. Data augmentation, semi-supervised machine learning. These are all things that actually, if you read the Google books that have been published, I think there's many Google books that are even free that are available on the Google Cloud or O'Reilly. They will talk about this. And then in terms of training the models, what are some of the file types? So these are things where the jargon could get you in trouble. Like if you don't know what Parquet is, for example, you should make sure you have a definition lined up, and also hyperparameter tuning. I think there's some nuance to this. For example, are you going to do a grid search, right? Are you going to basically linearly go through every single possible option, or are you going to use more of like a Bayesian system where you use basically heuristic to do things, or are you going to use some fancy statistical technique to pick the right hyperparameters? There's a lot of good documentation on Google about this. What are some of the metrics you care about, like root mean squared error, area under the curve, those kinds of things? And then concepts, like in terms of when should you redeploy? Now, the one that everyone talks about is data drift, right? So this would be a valid reason, is if the underlying data is changed by like 90% or something like that, right? It's likely you should probably retrain the model, right? Because the data is so different than when you first trained it. And then, also how often should you retrain it? Should you retrain every day, or should you retrain on a percentage? There's a bunch of documentation I would recommend you reading. In terms of testing the model, this there's explainability systems. So I think with this, I would say making sure you understand Vertex AI, and also in terms of scaling the model, Vertex AI. So I think a lot of experience with using Vertex AI is going to be your friend here. And then in terms of section 5, if you get into automating and orchestrating the pipelines, a few things to be aware of. Again, as I mentioned, if you've not used Cloud Build, Cloud Run, first of all, they're not that tricky. They're fairly straightforward. Cloud Run is a container-based microservice platform as a service. Cloud Build is their build system. Make sure you have some time to play around with this. The orchestration frameworks, things like Kubernetes hosted options like Kubeflow, Vertex AI, Apache Airflow. All these are important ones to know about. Know conceptually about what is hybrid multi-cloud. Understand how you would build out a serving system for an ML pipeline, including all this stuff down below: online, batch, caching, testing for performance, tracking and auditing systems. So this is really like also very architectural, this section. So I think by going through quick labs is where you're going to get that experience. And then monitoring, optimizing, and maintaining systems. This is really like operations type components here. to study for. So that's kind of just the high level. I just wanted to start off this first live stream and just set the context. And then what I'll do next week is I'll get into actual specific material, and I'll do some demos that cover, I think, in a linear way. I'm going to linearly go through this guide here and just show a little bit of stuff that will be helpful for each of these components. I think that's probably the easiest way to cover this material for the exam. So roughly, I think I'll be doing this every Thursday. So I'll see you next week. Okay, we'll share some links. There we go. Yeah, and I'll put some of these links in next time as well. And the guide would go here like this. Yeah. So basically, this whole machine learning guide here is what I would recommend doing. Perfect. All right. See you next week.